Okay, welcome back to lesson 5.3, and now we're going to actually jump into some problems. So here's our example. So find exact values using periodic properties. So what is the exact value of sine 17 pi over 4? Well, let's take a quick glance. Here is our unit circle. We'll bring that back in just a minute. So I have sine of 17 pi over 4. Well, I know everything with a 4 as a denominator for sine is either root 2 over 2, positive root 2 over 2, negative root 2 over 2, or negative root 2 over 2. So it's going to be root 2 over 2. We just got to figure out if it's going to be positive or negative. Okay. We know that by our denominator of 4. So now this is 17 power 4. So then we see, okay, how many times does 17 go into 4 or 4 go into 17? We think that's, 17 over 4 is 4 and 1/4. So 4, then there's going to be 4 pi. So then we think, okay, so that's going to be, we go around 2 pi, we go around 4 pi, then now we're right back here. So sine of 4 pi, of course, is still just going to be 0. But this is sine 4 pi or 4 pi and 1, okay? Because 17 over 4 is 4 and 1/4. So then I think of that, I go around twice, and then I go 1/4 more. So then I go around 2 pi, 4 pi, and then I go back up here to pi over 4, which is just going to be my root 2 over 2. So then that's just going to be the same thing as 17 pi over 4 is going to be the same thing as sine pi over 4, which is just root 2 over 2. And that's it. That is our answer. Okay, let's keep that a little lower so we can see that. Cosine of 5 pi. Well, that means we're going to go around twice and then one more pi after that. So if I look at my unit circle, then cosine are my x values. But I go around once, that'd be 2 pi. Twice, that's 4 pi. And then one more pi is 5 pi. And what is my cosine there? It's my x value, which is -1. So then that gives me cosine of 5 pi is -1. Tangent of 5 pi over 4. Interesting. So let's take a look at this one. So if I say tangent of 5 pi over 4, then that's like 5 over 4 pi, or in other words, 1 and 1/4 pi, right? So I know it has 4 as a denominator. So I know my sine and cosine are root 2 over 2 and root 2 over 2. And so then I just got to figure out where am I at on the unit circle. So I'm going around, okay? I'm going 1 pi plus 1/4 of a pi, okay? And actually I have that in my unit circle, 5 pi over 4, and that is right here at 225. So I can think I go 1 pi, and then I go pi over 4 more. So I'm right here at 5 pi over 4, so we know that one. And then guess what? Tangent is sine over cosine. So I think of tangent of 5 pi over 4 is sine over cosine, or in other words, my y over my x. And in that case, I had negative root 2 over 2 divided by negative root 2 over 2 because I was in the third quadrant where they're both negative. And so anything divided by itself is just going to be 1 because a negative divided by a negative is a positive. Root 2 over 2 divided by root 2 over 2 is just 1. So our first one, as it points out, is the same thing as sine pi over 4 because it's root 2 over 2. Went over that. And then our cosine pi plus 4 pi is the same thing as cosine pi, which was -1. And then our tangent, 5 pi over 4, okay, is the same thing as tangent pi over 4 plus pi, which is also still just 1. Okay, let's determine the signs of the trig functions in a given quadrant. So we will look at this, and this is pretty easy, the nice thing, but we'll think of trig functions as well. So what are the signs of our trig functions in each quadrant? Well, if I think, now we can look at our unit circle. Let me bring this down and let's look at this a little separately here. If I think of my xy axis and I think of cosine comma sine, all right? Well, tangent is sine over cosine. And then, of course, secant equals 1 over cosine, so it'll be the same as cosine. Cosecant equals 1 over sine, so that'll be the same as sine. So then really our tangent is sine over cosine, our cotangent is cosine over sine, so they will be the same sign. So then if we think of our cosine being our x and sine being our y, then really I just need to understand above my x-axis, my cosines will be positive, right? So I have positive, negative. Here I have, positive, positive, my bad. Here I have positive, negative. Here I have negative, negative when it comes to my x and y. And then here I have, oh, I switched that. I knew I was saying that incorrectly. Excuse me. My x is negative, my y is positive. So here would be negative, positive. Hopefully you caught that while I was saying it. Here my x is positive, my y is negative. So then there's my positive, negative. So one thing we think of as a shortcut is I think of all students take calculus. So this means all of our signs, our trig functions are positive. All our trig functions are positive. Okay. Here, all of our sine functions are positive because those are our y values, right? But then also we got to know that whenever our sine is positive, also our cosecant is positive. So we have cosecant as well that goes in there. Okay. But then we think of what about our tangent? Well, our tangent is sine over cosine. If I have a positive divided by a negative, then it's going to be negative. So then here, sine and cosecant are positive. Everything else is negative. Okay. Meaning my tangent, cotangent, cosine, and secant are all negative. So then here my T is for tangent. So my tangent and cotangent are positive because a negative divided by a negative is a positive. So those are my positive ones. Here's my positive ones. All the rest are negative, meaning cosine, secant, sine, and cosecant are negative. And then my last one is C for cosine being positive, and of course my secant because it goes with, and then all the rest are negative. Okay, tangent, cotangent, um, my sine, and cosecant. So that's just kind of a memorization there. All students take calculus, ASTC. All of them are positive. My sine functions, my sine and cosecant, my tangent, cotangent, and my cosine and secant. So let's take a look at what we deal with when it comes to problems in this situation. So here, did my freeze up here a little bit? Yep, we did. The computer's doing some thinking here. Hopefully it'll finish real soon. There we go. So it says here on the table, but that's kind of hard to memorize. So of course use your x, y coordinate axis, your cosine being positive, your x and your sine being your y. Okay, we are still in thinking mode, so hopefully this will get past this. There we go. Let me pause this till this is over. Okay, not sure if we got paused. There's seeming to be little technical difficulties here. Hopefully we're doing good. So here, all students take calculus. So that gives you a little bit of each one of these in a separate diagram. So finding the quadrant in which the angle theta lies. Well, let's see. If sine theta is less than 0 and cosine theta is greater than 0, name the quadrant. Well, let's see. Sine is less than 0 and cosine is greater than 0, then that just means my x is positive and my y is negative. So I think, okay, well, my x is positive, everything to the right, right? So I'm either in the first quadrant or the fourth quadrant. Well, my sine is negative, so that means I am in my fourth quadrant. Uh-oh, here we go. Let me move this up. So here, my x and my y. So if my x is positive, I'm this way, and if my y is negative, then I'm that way, so I have to be in my fourth quadrant. Okay, quadrant 4. So that's the easy way, I think, to think of those. All right, let's use values of the trig functions using fundamental identities. Okay, so here is our identities. Let's look at our identities. We've already covered all of the basic ones. Okay, and that is cosecant is 1 over sine, secant is 1 over cosine, cotangent is 1 over tangent, tangent sine over cosine, cotangent cosine over sine. So let's use a couple of these for finding some functions. So given sine theta equals root 2 over 2 and cosine is root 2 over 2, find the exact values of the 4 remaining trig functions. All right. Well, hopefully we know by now that since they're root 2 over 2 and root 2 over 2, we know it has a denominator of 4. They're both positive, so I know I'm right here at pi over 4 because that's where they're both positive root 2 over 2 and root 2 over 2. So the only thing I need to find is my secant, my cosecant, my cotangent, and my tangent. Okay, so we know those are all pi over 4 is my angle. What are they here? So my secant is 1 over cosine, right? So it'd be 1 over root 2 over 2. But when I have a fraction like this, it's like 1 over 1 over root 2 over 2. I bring this up and flip it and multiply, right? So then that would be 2 over root 2 times 1 over 1. Well, it can't have the square root as a denominator, so I'm going to multiply by root 2 over 2. And that's going to give me, let's see, I'm running out of room. Didn't give myself enough room here. Secant pi over 4 equals 1 over root 2 over 2 equal 2 over root 2 times 1, right? Got to rationalize my denominator. So that's going to give me 2 root 2 over 2. My 2's cancel, so I'm left with just root 2. My cosecant, pi over 4, is going to be the same thing, 1 over root 2 over 2. So that's going to give me also root 2. Well, let's look at my cotangent and tangent. So let's do tangent first, pi over 4. So this is my sine over cosine. Well, if it's root 2 over root 2 over 2, then that's just 1. And then, of course, my cotangent will be the same thing because it's just going to be those two flipped, but they're still the same thing. So there won't be any change. So that's how we're going to calculate these. So tangent, then that is root 2 over 2. That is a misprint. It equals 1. I don't know why it is saying 1/2 there. I will have to fix that. Whoops, let's take a look here. And then that's a misprint there because they are both positive of root 2 over 2 and root 2 over 2. So that's an obviously 1. And so this is incorrect. So I will fix that, but I don't know if it'll be fixed on the actual PowerPoints in the modules because these are made by Pearson. All right, cosecant we notice is root 2. And then secant. Did we do? Okay, yeah, these are wrong too. Look at that. I apologize. They're all root 2. I shouldn't have even used this. I'm going to delete that. the slide because that is incorrect. Okay, let's look at our Pythagorean identities real quick. So Pythagorean identities, first of all, cosine squared plus sine squared equals 1. That's our Pythagorean identity. Why? Because in our unit circle, our x and our y, what is our radius? Our radius is always 1. So we know with Pythagorean, it's a squared plus b squared equals c squared. And so if this is 1, then whatever my cosine is squared plus my sine squared, it's going to equal 1 on my unit circle. So that always comes out true on every single triangle and everywhere we go. So we know this is an identity. Well, we have two other identities that seem kind of challenging. Tangent squared plus 1 equals secant squared, or cotangent squared plus 1 equals cosecant squared. Well, let me show you why those aren't too challenging, and we'll go over those. So if I have sine squared plus cosine squared equals 1, well, I can just change those up to realize that we have two other identities. And what that might mean is if I divide everything by cosine squared, because this is an equation, so I can do that to both sides of the equation. It keeps it equal. So sine over cosine, then we know is what? Tangent squared plus, we know that's 1. And what's 1 over cosine? That is secant squared. So tangent squared plus 1 equals secant squared. Well, let's look at the other one. Sine squared plus cosine squared equals 1. That's our Pythagorean identity. What if I divide everything by sine squared? Okay, keeps everything equal. However, sine squared is 1, cosine squared is cotangent squared, and that equals cosecant squared. Okay, so that is our two other Pythagorean identities. Tangent squared plus 1 equals secant squared, cotangent. So don't try to think that you have to memorize those. You can just work those out and realize it's all the Pythagorean. It's just either divided all by cosine or divided all by sine, because we will use these. Okay, so let's look at some. So here's our fundamental identities, which we've all covered. So there's the identities we're going to use in this class. And what do we mean by identities and how we're going to solve these? Well, we're going to use these then to basically solve some problems. So our first one is cotangent 40 equals cosecant 40 over secant 40. All right. So find the exact value of each expression. Do not use a calculator. Well, your calculator will give you a decimal anyway, and that's not what we're looking for. We're looking for exact, and decimals aren't exact. So let's look at this problem. So we can just use our identities. We know cotangent is cosine 40 over sine 40, and that was a minus, not an equal sign. Minus, what is my, that was a cosine, cosecant. I knew that, I wrote that down wrong. So this was cosecant 40 over secant 40. Well, cosecant is 1 over sine 40 over 1 over cosine 40. Fraction over fraction, we flip and multiply. So this one we can rewrite as cosine 40 over sine 40. So let's rewrite that. So we bring this one down. We have cosine 40 over sine 40 minus cosine 40 over sine 40. Well, when we're adding and subtracting fractions, this is not getting rid of the whole thing, but we keep our common denominator, right? So this would be sine 40, but what's on the top? 0. And anything with 0 as a numerator is just 0. Okay, so that's how they work these out. If we look at the 1 over cosecant squared, okay, we're going to rewrite that as 1 over sine squared plus cosine squared, okay? So let's look at that one real quick. We have 1 over cosecant squared pi over 16 plus cosine squared pi over 16. Okay, so then when we have that here, this one we can rewrite as, well, let's just put it over here. This is going to rewrite as 1 over sine squared of pi over 16 plus cosine squared of pi over 16. Well, 1 over is, I'm just going to bring this up and multiply, so that's going to really turn into sine squared pi over 16 plus cosine squared of pi over 16. And what is that? We know sine squared of any angle plus cosine squared of any angle equals 1. So that one just equals 1. Okay, now let's find the exact values of some trig functions given the quadrant and an angle. So let's look at this. We have sine theta is 1 over 3 and cosine theta is less than 0. So how we're going to do this, they can kind of make this a little challenging, but I just like creating a triangle and then using my SOHCAHTOA, or how we know with our sine and cosine functions. So let's take a look. It says sine theta equals 1/3. Okay, so that's not on my unit circle. I'm going to have to create another triangle with that. So I'll show you. And cosine theta is less than 0. Okay, and cosine theta is less than 0. So cosine is my x. So if I think of my xy is negative, so I'm going to be over here in either 2 or 3. Well, my sine, let's write our SOHCAHTOA down here real quick. Let me put that over here on the left. So, okay, we write this as SOHCAHTOA. That means sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Write that. And then tangent equals opposite over adjacent equals. Okay, so that's our SOHCAHTOA. So I think opposite over hypotenuse. That is my sine. So when I think of sine theta equals opposite over hypotenuse, and this one equals 1 over 3, then I know my opposite is positive and my hypotenuse is always positive. So when I think of my triangle, I think of coming out here and like this. And this, my angle is always coming from the origin when I'm creating my triangle, because if we think of our circle, right, our unit circle. So then my hypotenuse is 3 and my opposite is 1. It's positive. So there's no way we could be over here in the third quadrant, or because that would have to be a -1, and my sine is positive. So I have a +1 and a +3. So I just need to find my cosine to then figure out the rest of my trig functions. So I know with a right triangle, I have a squared plus b squared equals c squared. In this case, my c is 3 squared. One of my sides is 1 squared. And then let's say I need to find my cosine, which is a squared. So I'm just going to subtract that. So a squared is going to equal 3 squared minus 1 squared, or in other words, 9 minus 1. And so a squared equals 8. And then I'm going to square root both sides to get a. So then a is the square root of 8. Well, I can simplify that. I know a perfect square I can divide that by. I can divide that by 4. So that's the square root of 4 times the square root of 2. And the square root of 4 becomes 2. So that's going to be 2 root 2. So my cosine value, or my x value, is going to be 2 root 2. Once I have all 3 sides of my triangle, then I can put down any of my trig functions. So then I can say Sine theta equals 1 over 3 because it's opposite over hypotenuse. Cosine theta equals adjacent over hypotenuse. And this is my adjacent because it's next to my angle. It's not exactly opposite my angle. My hypotenuse is always my hypotenuse. So my adjacent is 2 root 2 over 3. And then my tangent will be opposite over adjacent, or 1 over 2 root 2. And I can't have my root 2 on the bottom, so I'm going to multiply that by root 2 over root 2. Then I'm going to have root 2 over 2 times root 2 squared, which would be 4. So that's root 2 over 4. My cotangent is going to be 2 root 2 over 1 because it is just the inverse of my original tangent, right? Or the reciprocal. I'm sorry, not my inverse, my reciprocal. What's the reciprocal of sine? That is cosecant theta. So I'm going to just take that and flip it. So it'll be 3 over 1, or in other words, 3. And then my cosine will be this flipped, or my secant, I apologize. My secant theta would be 3 over 2 root 2 multiplied by root 2 over root 2. I'm going to end up with 4 on the bottom and root 2. So I'm going to have 3 root 2 over 4. So those are my other functions once I've been given that. So it says come up with the remaining 5. And there we go. Ooh, one thing I forgot and I need to be very careful with is, maybe you'll notice this, but my x value is negative. So I apologize, I did not show that in the video. So then that means anything that I have my cosine with is going to be negative, okay, or my adjacent. So here my cosine, that's going to be negative because I have a negative over my hypotenuse. My tangent is going to have a negative here. So that would make this negative because I have 1 over 2 root 2. Cotangent's also going to be negative. So there's my tangent. Here's my cotangent. Here's my cosine. Here's my sine. And then my secant, my cosecant will still be positive, but my cosecant will be, my secant will be negative. My cosecant will be positive. Okay, so I apologize. We're going left, so that's negative. Don't forget that. Okay, so then that gives us our negative and positive. Here, okay, given 1, same thing. Tangent is root 3 over 3. So I'm going to just use my SOHCAHTOA in that case. And then my sine is negative. So let's quickly take a look at that. Tangent theta is root 3 over 3. And my sine is less than 0. Okay, so my SOHCAHTOA, as I pointed out, sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. Okay, so then here my tangent opposite over adjacent, and my sine is negative. So that means I'm going to be down here, and since my tangent is positive, that means these both have to be negative for my tangent to be positive. So I'm going to be here in my third quadrant. Here then my opposite, which is my y value, is going to have to be negative root 3. And then my adjacent, or my hypotenuse, no, here we go. Negative root 3. And then my adjacent is going to be 3, negative 3. Okay, now I find my hypotenuse by doing my negative root 3 squared plus negative 3 squared equals hypotenuse squared, or in other words, c squared. Well, anytime the negative is squared, it's positive, and a square root times a square root is just going to be what's underneath, so that's 3. And this will be a negative times a negative, so that'll be 9. And so then this will be c squared. So c is going to equal the square root of 12. Well, that becomes 4 times 3, square root of 4 times 3. Square root of 4 becomes 2, so we have 2 root 3. So my hypotenuse would be 2 root 3, and it's always positive. So then just use your sine, cosine, tangent to come up with your all 6 of your trig functions. Opposite, adjacent, and hypotenuse with your SOHCAHTOA. You can write all of them. Okay. And then the last thing, I'll do this real quick, is our even odd properties. I know we've gone long, but our even and odd properties. This states if I take a negative angle of one of my functions, okay, sine of a negative angle is going to just equal the negative of the sine of the regular angle. So in other words, sine of pi over 4, okay, of course, is root 2 over 2. Sine of negative pi over 4 is going to equal negative root 2 over 2. Okay, that went off there. Why is that? Because my sine is my y value, right? So here's my positive pi over 4, and it's root 2 over 2. Here is my negative pi over 4, and my y value is negative down here. Okay? Now what would happen if I did my cosine of pi over 4? Well, that's going to be positive root 2 over 2. Well, down here, it's also going to be positive root 2 over, positive root 2 over 2, because that's my x value, right? And my x value is positive down here. Y value is negative. So my cosine value, even though I'm doing a negative angle, it's going to remain positive. Okay? So my sine of a negative angle is just going to be the negative of whatever we have there, of the positive. So you can think of that positive of sine, that angle, just add a negative to it. Cosine of a negative angle is just going to be the same as the positive angle. And then tangent of a negative angle is just like sine and cosecant. Since cosecant is 1 over sine, they're the same. Tangent and cotangent, since I have sine and cosine, both of them, then they're going to be like sine. So really the only two that remain positive, so I can take cosine of a negative angle, it's going to remain positive. Secant of a negative angle is going to remain positive. Positive. So whatever that might be. So make sure and look those over. For example, let's just do these. Sine of negative 30 degrees. Okay. Well, on my unit circle, I know sine of 30 degrees is 1/2. Okay. So sine of negative 30 degrees, since it's going to make it negative, it's going to be negative 1/2. Okay. That's how my even and odd properties are going to work. Cosine of negative pi over 3. Well, we know cosine of negative pi over 3 is equal to the positive cosine of pi over 3. So as long as I know cosine pi over 3, which is also 1/2, then I know my answer, and that is 1/2. Okay. Let's look at cotangent of negative 5 pi over 4. Cotangent of negative 5 pi over 4 is going to be the same thing as negative cotangent of positive 5 pi over 4. So what is cotangent of 5 pi over 4? Well, if I look at my unit circle and we recall, 5 pi over 4 is my negative root 2 over 2 and negative root 2 over 2, right? So cotangent is cosine over sine, so that's going to be negative of negative root 2 over 2 over negative root 2 over 2. Well, this is positive 1, but then since it's the negative of that, then it would be negative 1. Okay, that's how these work. And then tangent of 29 pi over 4. Well, let's do that one real quick. Tangent of negative 29 pi over 4. Well, we know that's going to equal negative of the tangent 29 pi over 4, the positive one, right? So I get that, and I just add a negative to it. Well, how many 4s go into 29? Well, I can think of that as what? 28 is 7, so that would be 7. And then how many do I have left over? 1 over 4. So that's going to be, if I think 7 now, I go 2 pi, 4 pi, 6 pi. So I'm basically starting at 0 here. And then 7 pi is going to be right here at pi. And then I do 1 pi over 4 after that. So whatever my angle there is, and since this is tangent, these are both negative again. So it's going to be similar to my cotangent, what I just did, negative root 2 over 2 over negative root 2 over 2. And that'll be positive 1, but then I put a negative in front of it. So it will also be negative 1. Okay, I hope that answered all of your questions. We are done with 5.3. Y'all knock out the homework and do well on the quiz. Have a great day.